In question 2 of this series, we're asked, find the moment of inertia about the x and y axis for the area under the curve y is equal to x squared from x is equal to 1 to x is equal to 3. In question 1, we derived the first formula. And what we did was we had a rectangle and we took horizontal strips all throughout that rectangle, and we found out that the moment of inertia of an area about the x-axis is the following. We didn't go through the proof of moment of inertia about the y-axis, but it's shown right here. The difference between finding the moment of inertia about the axes is that if you're finding it about the x-axis, you're using rectangular strips positioned along the horizontal to find the area underneath the curve. Whereas if you are finding it about the y-axis, the rectangles have to be positioned this way. So they're always parallel to the axis. Let's start by finding the moment of inertia about the x-axis. This part is easy. What we have to do is substitute our function into this y, where we end up with the moment of inertia about the x-axis is equal to a third times the integral between 1 and 3. Remember, it is with respect to x, so we can substitute these as our bounds. And I'll substitute x to the power of 2 into my function dx. This part becomes x to the power of 6 dx. This is fairly easy to integrate. We have a third times the integral x to the power of 7 over 7 when x is 3 and 1. Let's find out what happens when it's 3 and when it's 1. I know when it's 1 it'll be 1 over 7. How about 3? 3 to the power of 7 gives us 2,187. 2,187 over 7 minus this fraction. Putting this into your calculator, you should end up with 100, or approximately 104.1. Now, let's find the moment of inertia about the y-axis. We'll use this formula. I subscript y is equal to the integral between 1 and 3. X squared remains the way it is. Y becomes our function, x squared. Simplifying this, just like we did with the other one, we end up with x to the power of 4, the integral between 1 and 3 dx. The antiderivative of this function is x to the power of 5 over 5. We have to find out what that is equal to. 3 and 1. If you evaluate this on your calculator, you should end up with approximately 8.6. These are the two answers for this problem. And there you have it. That is how to compute the moment of inertia using integrals. Make sure to watch question 3, where we look at how to compute the moment of inertia for solid objects.